Today's lesson is 5.4, the Midsegment Theorem. We're going to start on page 287, the objective to identify and use properties of the midsegments of a triangle. And the new vocabulary here is midsegment. A midsegment is a segment that connects the midpoints of two sides of a triangle. For example, in triangle ABC, let's say that point D is the midpoint of the segment AB, and let's say that point E is the midsegment or the midpoint of AC, then DE is the midsegment. It's the segment that connects those two midpoints. So DE is the midsegment of this triangle. This leads us into Theorem 5.9, the Midsegment Theorem, which can be found on page 288 of your book. And the Midsegment Theorem, you want to get on a note card, says that the segment connecting the midpoints of two sides of a triangle, and remember we call that the midsegment, that's that line that connects those two midpoints, it's parallel to the third side, and it's also half as long as that third side. So if you look at this drawing, DE is the midsegment because it connects the midpoints D and E. D is the midpoint of AC and E is the midpoint of CB. And we can tell that those are the midpoints because we have these marks on the triangle that show that like CD is congruent to DA and CE is congruent to EB. So that means that D is the midpoint and E is a midpoint, and the line that connects those two is called the midsegment. Now what we know about that midsegment according to this theorem is that it's parallel to this third side over here. So DE is parallel to AB. And also what we know from this theorem is that DE is half as long as AB. So once you know that DE is a midsegment, then this theorem lets you know these two things about DE. So the example problems that I'm going to be showing you is page 290 and 291, numbers 10 and 11, 12 through 18 even, and number 26 and 28. I'm actually going to start with number 12. We're going to come back to 10 and 11 in a minute. But number 12 says LM is parallel to which side of the triangle ABC. So LM is right here, and it's the midsegment because L and M are both midpoints. So it's parallel to side BC. So the answer to number 12 is BC. Okay, on number 14, it says if AC equals 20, then they want us to find LN. So I know that this big side down here, AC, is 20, and I'm trying to find LN. Well, LN is a midsegment, and it's parallel to AC, and by Theorem 5.9, we also know that LN is half of AC. So LN then has to be 10. Okay, number 16, if NC equals 9, then how much is LM? So NC is equal to 9. That also means that BN is equal to 9 because those two are congruent. It shows us that with these little marks here. So that means the whole side BC is 18. Well, we know that LM, which is the side we're trying to find, is parallel to BC, and it's also half of BC. So half of 18 is 9. So LM is also 9. Okay, on number 18, if MN is equal to x minus 1 and AB is 6x minus 18, then they want us to find the length of AB. So let's go ahead and label our drawing here. MN is x minus 1, and AB, this side over here, is 6x minus 18. Now the relationship between MN, which is this side here, and AB is that they're parallel to each other because MN is a midsegment. And we know that MN is half of AB. So MN is half of AB. So they gave us some algebraic expressions for those two segments. So we can substitute those expressions. MN is x minus 1. And AB, we're going to take half of it, is 6x minus 18. Then we can solve for x, and then we'll be able to find the length of AB. So I'm going to have to distribute with a half. Half of 6x is 3x, and half of 18 is 9. So I've got 3x minus 9 equals x minus 1. I'm going to get my like terms onto the same side of the equation. So I'm going to take 9 and make it positive 9 minus 1. And my x's will be 3x plus negative 1x. So that's 2x is equal to 8. Divide both sides by 2. So the value of x is 4. That's not the answer to the question, though, because they want to find the length of AB. I know AB is represented by the expression 6x minus 18. So I'm going to substitute 4 in place of x. So 6 times 4 minus 18, that will be the length of AB. So 6 times 4 is 24, and 24 minus 18 is 6. So the length of AB is 6. Okay, I'm going to jump back to numbers 10 and 11 now. Number 10 and 11 aren't really that difficult, but we're going to do something further with this that you're going to need on number 21 and 22 of your homework. So we're going to use 10 and 11 to kind of show you how to do 21 and 22. So first, number 10 says just basically what are the coordinates of points A and B. So the big thing you got to recognize on this is that both on the x and the y axis, they're counting by 2's. So point A is going to be 1, 4, and point B is going to be 6, 6. Now AB is the mid-segment because A and B are both midpoints of their sides. And it tells us in the problem number 10 that AB is a mid-segment. So on number 11 it says that each unit in the coordinate plane represents 10 yards. So use the distance formula to find the length of the new walkway. And in question number 10 they said that AB is the walkway. So we're trying to find the distance. How long is AB? So we're going to use the distance formula to do that. And we've got to know that it says that every unit is 10 yards. So that means that we need to multiply our coordinates by 10. So that means that A is really 1040 and B is really 6060. So those are the numbers we're going to use in our distance formula. So remember, distance is the square root of y2 minus y1 squared plus x2 minus x1 squared. And it's the square root of all of that. So we'll fill in our formula. So I've got 60 minus 40 squared plus 60 minus 10 squared. And let's go ahead and do that math. So 60 minus 40 is 20, and 60 minus 10 is 50, and we're going to square each of those. So 20 squared is 400, and 50 squared is 2,500, and we'll add those together and take the square root. When you add those together, you get 2,900, and so the square root of 2,900 is about 54 yards if you round it. So we're going to put approximately 54 yards. So I want to take this problem a step further because you're going to have to do this on number 22 of your homework. And I want you to verify that AB is really parallel to OR. So remember that the midsegment theorem 5.9 tells us that AB is parallel to that other side, because if it's a midsegment it is, but we're just going to verify that. So remember that we know that parallel lines have the same slope. So the way to verify that is to find the slope of AB and find the slope of OR, and then we can show that those two slopes are equal. So let's start by finding the slope of AB. Remember, our slope formula is y2 minus y1 over x2 minus x1. So we'll take y2, 6, and subtract y1, 4, over x2, which is 6, and x1, which is 1. So the slope of AB is 2 over 5. Now let's find the slope of OR. So y2 is 4, y1 is 0, x2 is 10, x1 is 0. So 4 over 10, and that reduces to 2/5. So the slopes are equal to each other, so therefore the lines are parallel. Okay, the other thing you're going to have to do on number 22 is not only verify that those two, the mid-segment and the third side, are parallel to each other, but you're also going to have to verify that the mid-segment and its parallel side, the mid-segment is half of that parallel side. So we're going to do that next. Now, remember, we've already found the distance of AB. We did that back on number 11. Now remember, we multiplied our coordinates by 10 on that one. So it doesn't really matter what you do here. You can either go ahead and multiply your O and R coordinates by 10, or you can just divide the distance you found in number 11 by 10. So really AB, if we do that, AB we know is 5.4 units. That's the distance of AB. We got 54, but that's because we multiplied our coordinates by the 10 yards. So really AB is 5.4 units. So OR should be about 10.8 units. This was approximately because I don't think it was an exact square root. So we're going to go ahead and find the distance of OR, and that should be twice the distance of AB. So we'll use the distance formula. So we've got 10 minus 0 squared plus 4 minus 0 squared. So that's going to be 10 squared plus 4 squared. 10 squared is 100, 4 squared is 16. We'll add those together and then take the square root. So the square root of 116 is approximately 10.8 units. So we have verified that AB, which was 5.4 units, is half of OR. Okay, to me the most challenging problem on the homework is probably number 27, and I'm going to do number 26 to help you with number 27. So on number 26 and 27, you're given the midpoints of your triangle, but what you're not given are the endpoints, and that's what you're trying to find on 26 and 27. So you want to start by graphing your midpoints, and I'd go ahead and do 26 along with me on a piece of graph paper, and that will help you with number 27. So my midpoints are 1, 3, 5, 9, and 4, 4, and I'm going to graph those on this coordinate plane. Okay, I've got my midpoints graphed, L, M, and N, and just to make you aware that on my x-axis I went by 1s, and on my y-axis I went by 2s to make this fit on this coordinate plane. So the next thing that I want to do is I want to find the slope of each one of these mid-segment lines, because what I know is that the slopes of the opposite sides are going to be parallel to these mid-segment lines. So if I can find the slopes, then I can find some more points, and that will help me graph the big triangle that these mid-segments are inside. So to find my slopes, since these are graphed, I could do rise over run. So for LM, if I started L, I would rise 6 and I would run 4. So 6 over 4 reduces to 3 over 2. For MN, if I started N, I would rise 2, 4, 5 and run 1. So the slope is 5 over 1. And for LN, if I started L, I would rise 1 and run 3, so the slope is 1/3. Okay, so this next part is the part that's a little bit tricky. So what you want to do now is, you know that the actual side of the triangle that point L is a midpoint of, if that side is going to be parallel to the opposite side, which is MN. So since the slope of MN is 5, then the side that goes through L also has to be 5. So we're going to start at point L, and we're going to do a slope of 5 and make another point. So going up 5 would be here from L, so that's 1, and then plus 2, so that's up 5, and then over 1. So another point on that side is there. Now what you want to do is draw a really long line, and as straight as you can, from the point we just made through your mid-segment L, and we're going to make that line really long because we're going to have to connect these, and eventually they'll cross and you'll be able to find the triangle. Now hopefully your line is straighter than mine because you have a ruler, but we're going to make that line really, really long. Now let's do the same thing. So with the mid-segment M, and we know that it's going to be parallel to the opposite side, which is going to be LN. So LN had a slope of 1/3. So that means from point M, I need to rise 1 and run 3, which is actually going to be off of my graph. So I'm going to go down 1 and left 3. And that actually is right here where we had our other point, right here. If I go down 1 and over 3, it's at the same point. So we're going to make a line through M, and then the point we just made by going down 1 and left 3, because I couldn't go up 1 and right 3. So let's draw a line through those. Okay, there's my line. That's the M is the mid-segment of, and it's parallel to LN. I've got one more to do. I need to draw a line through N, and it's going to be parallel to the opposite side, which is LM. So LM has a slope of 3, 2. So I need to have a slope of 3 over 2 here. So from N, I want to go up 3 and over 2. So I'm going to go up 2, and then halfway is 3, and then over 2. So there's a point that I can connect to N. So let's connect those 2 points and see if we can find all of our vertices. Okay, there's my last side, and you can see that where the lines cross are our vertices. So we have a vertex right here at -2, 0. That's one of our vertices. And then I have a vertex up here at 2, 8. And then this last vertex is somewhere over here. It's kind of off of my graph. But that one is going to be actually 8, 10. And if my graph was a little bit bigger, we would have been able to see that. But that one is 8, 10. And I have some bigger graph paper if you need it for the one on your homework. Okay, the last problem that we're going to work on is number 28. And we're just supposed to find the perimeter of this triangle. And they've given us some information here. They've told us that side CD is 14, GF is 8, and GC is equal to 5. And they want us to find the perimeter. Well, I need CD, which is 14. I need BC, and I also need BD. Well, because GC is 5, that means that BG is 5 because those are marked as congruent. So that means that BC is 10. So now I just need my third side, BD. Well, I know that GF is 8, and I know that GF is half of BD because it's a mid-segment. And so that means that BD has to be 16. So we can just add those up, and that will be our perimeter. So the perimeter of this triangle is 10 plus 14 plus 16, which is 40. So your homework is page 290 to 291, numbers 13 to 17 odd, number 21, 22, 27, and 29.